Hey guys, welcome back to another video in my series where I'm breaking down every topic in A-level maths. Today we're looking at quadratic equations. This is going to include looking at the definition of a quadratic equation, how to solve quadratic equations by factorising and completing the square, as well as quadratics in disguise. We're going to be using some of the concepts I talked about in my straight lines video, specifically how we generate a graph. So if you haven't seen that already, the link's in the description. Every section of this video is going to be timestamped, so you can easily jump to a section or rewatch a section. Hope you find this helpful. Quadratic equations are equations of the following form. The numbers multiplying the powers of x are called coefficients. We would refer to a as the coefficient of x squared, and b the coefficient of x. The graphs of quadratic equations form the shape of a parabola. We know the y-intercept for any graph occurs when x equals 0. Using the equation, we can see the y-coordinate will always be c. We refer to the x-axis intercepts as the roots of a graph. These always occur when y equals 0. So to find the roots, we need to solve the quadratic equation. One way to solve quadratic equations is by factorising. Let's take the example 2x squared minus 3x plus 1 equals 0. We can factorise this to 2x minus 1 times x minus 1. This would mean our solutions would be x equals a half and x equals 1. To see why, let's substitute x equals a half into the equation. This simplifies to 0 times minus a half, so we can see the factors give us solutions because as soon as one factor is 0, the other factors don't matter, as multiplying anything by 0 gives us 0. We can similarly see that x equals 1 causes the second factor to be 0 when substituted in. Hence why it too is a solution. In general, it's worth remembering any equation with a factor of dx minus e will have a root of x equal to e over d. We can also solve quadratic equations by completing the square. Completing the square means to rewrite a quadratic equation in the following form. To see how this is done, let's consider the example x squared minus 4x plus 3. To start, we take the coefficient of x, minus 4, and divide it by 2 to get the term that goes in the squared bracket. If we were to expand that squared bracket, we would get x squared minus 4x plus 4. However, we need plus 3 rather than plus 4, so to correct we can simply take away the 4 and add the 3 back in. Simplifying down, this would give us y equal to x minus 2 all squared minus 1. Let's now use this form of our quadratic to solve for its roots by setting y to 0. First bring the 1 to the other side. Now square root both sides. Bringing the 2 over the other side gives us x to be 2 plus or minus 1. This would give us solutions of x equal to 3 and x equal to 1. We also need to be able to complete the square when the coefficient of x squared is not 1. Let's take the example y equals 2x squared minus 5x plus 3. When the coefficient of x squared is not 1, we need to first take it out as a factor. Now we can repeat the steps from the previous example. First, we halve the coefficient of x to get the second term in our squared bracket. If we were to expand the bracket, we would get x squared minus 5 over 2x plus 25 over 16. To fix this, we can simply subtract the 25 over 16 and add the 3 over 2 back in. Simplifying gives the following. Now remove the outer bracket by multiplying by 2. Let's use this form to solve the equation for its roots by setting y equal to 0. Move the 8th to the right-hand side. Divide both sides by 2. Square root both sides. The square root of 1 over 16 is a quarter. Move the 5 over 4 to the right-hand side. This gives us the solutions of x to be 3 over 2 or 1. Some equations, although technically not quadratics, can be interpreted as quadratics. Let's consider the example y equals x to the 4 minus 5x squared plus 4. We can actually treat this as a quadratic equation because x to the 4 can be written as x squared all squared. So we would say this is a quadratic in x squared. Let's now try to find the roots of our equation by setting y equal to 0. To recognize this more easily as a quadratic equation, let's use the substitution u equals x squared. Rewriting the equation in terms of u gives the following. Now factorize. Now let's use our substitution once more to rewrite our equation back in terms of x. Now we can further factorize this to deduce all the roots of our equation. These factors would give us solutions of x equal to minus 1, 1, 2, and minus 2. We can create a quadratic equation in terms of any function. In general, a quadratic in disguise will have this form. If we are inclined, we can use the substitution u equals f of x to rewrite the equation in a more familiar form in terms of u. So that's the end of the video, guys. Here's a little summary of everything we looked at today. If you found this video helpful, please drop it a like, that helps me out a lot, and consider subscribing to the channel to stay tuned for when I release new videos. Thanks, and I'll see you in the next one.